Welcome back to this lesson. So in this lesson, we'll be looking at lesson 4 of domain 1, Microsoft agentic AI business solution architect, AB-100, exam preparation. So plan AI power business solution, architect agentic first business outcome with Microsoft AI App Foundry, Copilot Studio, Dynamic 365 Power Platform, and governed enterprise data. So we are still on domain 1, which carries 25 to 30% of the entire examination question. So plan domain weighting, agentic first, autonomy, orchestration, grounding, business value, ROI, TCO, and secure adoption. So let's look at what we have next. So on this page, we have reference architecture. So the last thing we discussed is RAG architecture. Now let's look at reference architecture. So Azure data and AI flow for agents. So how does data flow from Azure ecosystem? Okay. So to generate data from Azure ecosystem like Fabric or Azure SQL database, Azure Data Lakehouse Gen 2, Azure Synapse Analytic, Azure Cosmos DB, for instance, the flow will go this way. So you have your business systems, okay? You have your operational database. These are transactional database like Azure SQL database, can be hyperscale or critical or business database. So these are just transactional database that is stored on Azure, deployed and provisioned on Azure. It can also be Azure SQL Server on Azure. It can be, or so it can be my SQL Server on Azure. It can also be Postgres database. It can be Azure Cosmos DB. Anything. It can be unstructured data in Azure Cosmos DB. So you have the operational database connected to lakehouse and warehouse. So this is data engineer. This is just like ETL architecture, basically. Okay, so it is data engineer that will implement this. So as a solution architect, agentic AI solution architect, you're also working with data architects, and you are working with an Azure architect, an Azure solution architect, okay, to understand this better. So you have the lakehouse architecture, warehouse architecture. This will happen when data has been collected from operational database, transformed and processed into lakehouse, bronze, silver, and gold layer, and they're stored in warehouse or schema, modeled into fact and dimension table in the warehouse. And then you have the search plus vector index. So this search plus your vector index connect to the warehouse lakehouse to embed, to ingest, embed, to ingest, chunk, and embed, and store this data as context and index data in vector database. Azure SQL database also now supports a vector store, and Cosmos DB supports vector store, and then you can use the standard one in the Azure AI ecosystem, which is Azure AI Search. So, which is basically designed as a vector database. Okay, you can also use PG vector on PostgreSQL on Azure, which also supports vector storage. And then the agent connects to the vector database. So you can see that the agent doesn't connect to the lakehouse or warehouse directly, because that is why you have the historical data. So you cannot connect the agent to the entire historical data. You connect the agent to the vector database, and your vector database is also built based on domain. So you are building a vector store for procurement, vector store for supply chain, vector store for finance, vector store for IT, vector store for for HR, vector store for all the domain. Then you connect the vector store to the agent that specializes in each domain. Okay, and then you have your agent, whether built in Copilot or in Azure AI Foundry. So Azure SQL, Cosmos DB, Dataverse, Fabric, Azure Storage, Microsoft Graph provide core enterprise data sources within the Microsoft ecosystem. Azure AI Search and vector indexes ground AI applications and agents. So this is basically the original Azure AI, vector database, okay, which is what you can also use for your vector indexes originally. Then AI ready components. So data architecture component for enterprise AI. We are still discussing much about making the data AI ready in terms of data. So architecture. So the first thing we have said is determining the data sources, whether they are within the Microsoft ecosystem. And the next thing is building a centralized data lakehouse and warehouse, and then building a RAG database from the lakehouse and warehouse, connecting agent. So what should the data architecture component of an enterprise AI look like? So look at this component and architecture rules. The repository, first repository of unstructured data, files, Excel, CSV, document, PDF, Word document, everything can be stored in SharePoint, OneDrive. Okay, so this can be used for document grounding, knowledge access, enterprise collaboration content, and policy implementation. Then we have Dataverse. So these are storage of data generated from Power Platform, automation, and the rest. So these are business application data, okay, Dynamic 365 data model, secure app integration. So these are business where business data are stored. Any data generated by business application or built from Power Platform can be generated from Dataverse. Okay, like Dynamic 365 data can be generated from Dataverse, and the secure app integration as well. Then we have Azure Storage. This is Azure Data Lake Storage Gen 2, or Azure Blob Storage, or Azure File Storage, Queue Storage, and so on and so forth. So document and blob storage for pipelines and knowledge assets. So this can serve as a lakehouse, okay, for implementation. Then we have semantic indexing. This is manage meaning-based retrieval and contextual grounding. So semantic indexing data is stored in Azure AI Search, PG Factor, or Azure Data SQL database for semantic indexing, or Azure Cosmos DB. And then we have graph connectors. So bring external system into Microsoft 365 Search and Copilot context. So any source that can connect to graph, like one Outlook, email, Teams, you can use graph to connect to all these sources within the Microsoft 365 ecosystem to bring data into the Copilot or to connect to the agent. Then Microsoft Purview. So Microsoft Purview ensures governance, guardrail, data lineage tracking, DLP, sensitivity level, GDPR, and HIPAA implementation and compliance control. So everything still sits on top of Microsoft Purview governance and guardrail, okay, with role-based access control, least privilege, sensitive data reduction, encryption, and secure operation. Database strategy. So AI-ready databases and vector capabilities. So yeah, currently, I told you before that Azure SQL now supports RAG database. Yeah, so these are, thank God, these are AI-ready databases that are currently being implemented on Azure with vector capabilities. Azure SQL database so support vector search, semantic search, JSON support, operational AI app. So Azure SQL database is no longer only used for transactional data or operational as an operational database. It can also now be used for vector search, semantic search, JSON support, and operational AI app. Then we have Cosmos DB. I told you before as well that Cosmos DB now supports vector indexing and low latency AI application. We have PostgreSQL. PostgreSQL support embedding. It supports embedding an AI extension through the PG vector. Microsoft Fabric. Microsoft Fabric is a unified analytic platform with Lakehouse warehouse and Azure SQL database hosting, and even or you can also host Cosmos DB, MongoDB, and other document database. So unified analytic platform for curated data and AI-ready lakehouse patterns. Then use cases. So use cases, all these databases and warehouses storage can be used for RAG, embedding storage, AI agent, and real-time decision making. So these are as databases and platforms that you can use to store AI-ready data on Azure. Let's look at strategy foundation. So how do you ensure that the enterprise implement cloud strategy. There's what we call cloud strategy, which is driving enterprise to adopt cloud implementation, and they store most of their application on the cloud for security and for easy access and for scalability. So cloud adoption framework, CAF, plus AI agent lifecycle. So this is what the architecture of cloud adoption framework and AI lifecycle look like. The first thing is strategy. Okay, the company must be implementing strategy. It encourages strategic storage, strategic hosting, strategic decision making, strategic day-to-day operations within the business, thereby improving security, access, and a unified platform for application deployment and data storage and operational data hosting. So first thing is strategy, then planning. So when the company adopt a cloud strategy, then the next thing is planning, how to migrate all the on-premise database, on-premise application to the cloud. So you plan it, you develop the plan. It's normally a very large project that can span 1 year, 2 years, depending on the capability of the consultant that the company is bringing in, and the financial capability. So the next thing is, if the company adopts cloud strategy, the next thing is planning. So the first thing basically is to make the company or organization understand cloud strategy. So explain what cloud can do, what value cloud can add to the business, how cloud can host the application for security, host database for security, host data analytic warehouse, lakehouse for scalability data, scalable data platform, and visualization, reporting generation, machine learning application, and generative AI integration. So after that, you planning. So that is if the company adopt the strategy, the next thing is planning. It is planning migration, planning or how to move on-prem data, what should remain on-prem, what should move to the cloud, what database should be on-prem, what database should be on cloud, what application should be on-prem, what application should be on cloud per domain. Okay, as you are migrating application, you are also migrating per domain, not the entire company. You migrate department by department. Okay. The next thing is ready. So after planning it, the next thing is to make everything ready, assess everything. So plan everything, plan the cloud, plan the on-premise system, then assess everything for readiness, assess all the application, the database, or the platform or repository of data for readiness. After assessment, then you implement governance and security. So you connect to the sources through governed and secure connection using API, using graph connection, and so on and so forth. And then after establishing governance and security, the next thing is to build. So you now start building the platform on cloud. After building domain by domain, department by department on cloud, then the next thing is to deploy and then start operating. So this is the cloud adoption with an agentic AI lifecycle built together in one. So combining cloud adoption framework phases with agent lifecycle activities, plan agents, govern and secure agent, build agent, deploy agent, and operate agent. So cloud adoption combine agent lifecycle in this flow, and you can also adopt this flow as an AI solution architect. Of course, you should also have knowledge of Azure Cloud. Very, very important. So the goal is avoid agent sprawl, standardize decision, and accelerate AI value delivery. So AI is best operated, is best useful when it is deployed on cloud, not on-prem. So plan using cloud adoption for AI deployment. Okay, and if you are building multi-agent, custom multi-agent, should be thinking of deploying using Azure Kubernetes service or Azure Container Apps. For simple agent, you can use Azure Container Instance. That's if you build custom agent. And if the agent is built simply in Copilot, then you use Power Platform cloud adoption instead. Okay, and then you deploy using Power Platform pipeline and manage using application life cycle in Power Platform. That's ALM. From business outcome to operated agents. So AI adoption process. So these are the processes and the architecture term that you should use for AI adoption process. So from business outcome to operated agent. As an AI solution architect, you are not just architecting AI, you are also, you don't just have understanding of agentic AI architecture, Copilot, Office 365, Dynamic 365, or Azure knowledge. You should also have business process knowledge, and that is why you are working with domain experts. That is why you are working with business experts. That's why we are working with CEOs, with CTOs, with CFOs. You are working with business leaders. You are working with business stakeholders, and you should also understand a business process, because when you understand the business process, you'll be able to make the business owner adopt the use of agent to, plan strategically and to implement this repetitive task to generate value or for the business. So what should you be looking at, or what should you look at when you are explaining AI adoption process? The first thing you should think of is strategy. So strategy help you identify outcomes, prioritize use cases, define ROI, and select SaaS, okay, Copilot Studio, Foundry, or infrastructure. So strategy is very, very important. To make the company adopt cloud platform, you have to understand cloud strategy, okay? So to even explain agentic AI solution, you have to understand agentic AI strategy. You also have understanding of AI infrastructure, whether on Copilot, Azure AI Foundry, deployed on Azure or on Power Platform. Understand the infrastructure. Be able to differentiate infrastructure based on the platform for deployment. Differentiate Power Platform deployment from Azure DevOps deployment. Differentiate hosting, Power Platform hosting from Azure Kubernetes or Azure Container Hub hosting, and know when to use different infrastructure for different scenarios. So strategy is very, very important. Identify outcomes, prioritize use cases, define return on investment, also define total cost of ownership, define strategic risk mitigation, and secure adoption. Secure adoption, very, very important. Select the SaaS solution, software as a service, that you want to build. Select the platform that you want to use, whether Copilot Studio, or if the agent is simple and then you want to integrate with Office 365 and Copilot, then think of Select Foundry. Select Foundry if you want to build multi-agent and custom agent that will be deployed on Azure, on Kubernetes, or container apps, or container instance, and so on and so forth. And then also properly strategically choose your infrastructure and design strategically. Very, very important. Then after your strategy, so this is what you should look at in your strategic decision making. After your strategy, you should plan. So plan is to assess the skills that you have gathered from the business experts, business owners, and domain experts. Assess those skills. Skills are generated from day-to-day activities and processes. You generate skills from business process, from business workflows, from business solution patterns, from pain points. That's where you generate the skills from. So assess the skills, run POCs, okay? So POC is, the initial, implementation. So very, very important that you run POCs so that they will have insight into how the application will work, what the platform will look like, and how the solution will be of help to the business, and then whether the solution is even trustworthy or not. So that will be determined through POC. So run POC, okay, or in agent you can call it MVP. So build a simple one, let them test, then before you start building the larger model. Then define readiness criteria and map dependencies. So define readiness criteria in terms of data, in terms of adoption, in terms of platform, in terms of infrastructure, and so on and so forth, in terms of cloud computing as well, even in terms of financial decision making. So map dependencies. So map all the dependencies together. Very, very important. Then after planning, check readiness. So create lead landing zone. So readiness, you need to have the landing zone. If you are building in Copilot, landing zone should be Power Platform. If you are building on Foundry, landing zone will be Azure, for instance. Okay, Azure Container Apps or Kubernetes for multi-agent. Then create landing zone, governance, role-based access control, least privilege, and so on. Create data architecture. So data architecture on SharePoint, OneDrive, OneLake, Fabric, Warehouse, Lakehouse, and so on and so forth. After readiness, then the next thing you should implement is governance and security. So apply policies, okay? Apply policies, manage risk, get role-based access control, get access to the data that you need, okay, and give access to the agent as well. Or secure models, build secure model, secure your models. Okay, do not just expose the model to all the people in the organization. Limit agents model, limit agent access to the domain that you are building for. Okay, give the agent, the business owners, access to the agent. If they are not the business, if anyone is not the business owner, do not give them access to the model. So secure the model, secure the agent. Choose your, after secure models, choose the agent. So choose your agent that you want to build. Is it one agent? Is it two agents? Three agents, and so on. Choose your agent, choose your tools, and choose your data that you want to connect to. So make all these things ready in terms of governance and security. After governance and security, the next thing is to build and operate. Build, deploy, and operate. So this is building the agent either in Copilot by connecting or workflows together. Choose your base model, ChatGPT, Claude, or any model available in Copilot or Foundry that you want to use, and make sure you also put in return on investment, total cost of ownership. If the tax is very simple, use simple model. If the tax is a little bit complex, move to medium model. If you are building complex system, then choose large model. Okay. Standardize deployment. After building, then standardize, choose your tools. When you choose your tools or connect data sources, and they fine-tune, develop your prompt, system prompt, user prompt, and fine-tune them, okay, based on the skills that you have acquired. Standardize deployment. Use standardized deployment using Power Platform pipeline. If you are deploying, building a Copilot, CI/CD, GitHub, Git and source control, using Azure DevOps and Azure DevOps pipeline, build evaluation, observability metric like return on investment, TCO, risk mitigation, tracing, correlation ID. So get evaluation data through observability platform. Then monitoring, evaluate the AI whether it's meeting business standard. Then monitor platform, monitor this agentic AI solution using application insight or analytic platform on Copilot. Observability, observe using Azure, or monitor using Azure Monitor. Okay, and you can collect telemetry, log, and metrics from the agent using observability tool like application insight. And then also manage cost management on Azure if you are using Azure, or use observability metric to also collect track token usage and manage cost. Very, very important. So the architecture terms that you should look at here are strategy, plan, ready, govern, operate. So we have looked at the flow here. Yeah, we have the flow here: strategy, plan, ready, govern, secure, build, deploy, and then operate. So they still follow this architecture. So this is just the in-depth breakdown of what you are doing in each of these stages. So each stage, you can see that each stage is dependent on the previous stage. So you cannot jump from strategy to building. It's not possible. So you implement strategy. Look at strategy. Strategy is requirement understanding, platform understanding, agent understanding, and source data understanding, architecture understanding, and so on. Then planning. So choosing your skills, running POC, and the readiness criteria and map dependency ready. Then So ready is deployment of landing. So deploy infrastructure, deploy infrastructure, implement governance and policy, manage risk and so on, and then build and operate on the platform. So they still follow the architecture that we have discussed. So thank you for listening. When we come back, we'll continue into the next section. If you are just joining us, please kindly like and subscribe.